Hello, and welcome back to another episode of Science Fiction Power Scaling. And today I'm going to talk about some general concepts as to power scaling regarding energy shields. Now, energy shields, we see them in a few different not scientific, what am I talking about? Scientific fiction. Why would I even phrase it that way? We see them in a few different science fiction universes. For example, three examples off the top of my head that many people would be able to recognize. You've got Star Trek, Star Wars, and of course, Stargate. All of them make varying uses of shields with varying degrees of effectiveness and also different ways that the shields work. There's many different, different ideas as to how energy shields should work. Because, of course, energy shields aren't really based on anything that exists in real life, or at least not that I know of at the time of making this video. There isn't really any known way to use energy in a way that puts it in a very specific place and blocks other forms of energy or kinetic attacks from one direction while still allowing whatever's on the other side to move around. So that doesn't exist in real life, or at least as far as I know. Now, of course, this means that there is a lot of artistic liberty in how varying authors and writers and directors and special effects artists can represent that in science fiction. So what's important in regards to power scaling is that there's different kinds of feats regarding shields. For example, some shields can not block certain kinds of energy, or some shields can block specific kinds of energy, and sometimes there's ways to circumvent shields so that a type of energy that would usually be blocked by a shield is not blocked at all, even though that energy passes through where the shield is active. For example, Star Trek. In Star Trek Generations, the shield frequency that the Enterprise was using got found out by some Klingons, and they managed to use that to circumvent the shields of the Enterprise when attacking. In addition to that, another type of that we see is, again in Star Trek, modulating shield frequencies in order to hit the Borg, or in order to deal more effectively with the Borg's attacks, because the Borg can rapidly change the frequency of their energy attacks in order to pass through shields. So, of course, shield frequency in itself is another issue, and that is regarding whether or not shields oscillate, because some shields can be considered a consistent energy, other shields oscillate in energy, and that's where you get to shield frequency. Now, another thing to be noted is the difference between holding out for a long time against something that hits the shields, or holding out for a short time against a brief but high magnitude energy burst. For example, let's say it's in Star Trek and somebody's firing a photon torpedo and it hits the shields, and for some reason the shields absorb the blast and everybody's fine. That's a short but extremely powerful burst of energy that is at least in the megaton range, depending on where in Star Trek you are, it might be more or less inside of the megaton range. I don't know if any of them would ever get into the gigaton range. You'd need a pretty large amount of antimatter to get that. But of course, there are calculators for that, and that's an entirely different issue. I don't want to get sidetracked on that. And with staying with a prolonged output of energy going onto the shields. For example, this has happened, to my knowledge, both in Star Trek and in Stargate, where someone puts a spaceship close to a star, and of course, the issue is that the radiation from the star is hitting the spaceship, and some of it is being absorbed by the shields, but oftentimes it is written so that not all of it is absorbed by the shields, and the heat inside of a spaceship is rising. Now, it's important to note how physics works in this is that the heat transfer from the star to the spaceship is essentially goes the same way as the heat transfer from the sun to the planet Earth, because, of course, the interplanetary medium is very sparse, and therefore is not very sparse in particles, and therefore is not useful for transferring heat through the general kinetic contact that usually occurs. For example, if you light a fire, the air around the fire has a lot of heat, and that air then spreads nearby, and the heat spreads from the molecules in that air that got heated by the fire to nearby molecules, and you can even reach the heat from a fire when you're not in eyesight of a fire because of that. Same thing with the sun to the same extent, so I don't know why I made that example. But anyway, so the reason that the sun's rays cause heat on the Earth isn't because they're heating a medium that then passes all the way from the sun to the Earth. No, it's because they're hitting the Earth's atmosphere, which of course causes heat, and then that heat spreads kinetically, and also because they are hitting specific objects on the Earth's surface, such as the trees, maybe some pavement. If you are in a place where it gets really hot in the summer, really be careful, because I've heard that some people actually can get burned on hot pavement. And another thing is the radiation hitting on people, of course, which can cause sunburns with prolonged exposure and increases your risk of cancer. So it's the radiation that from the immense energy and heat of the sun that causes the electrons to essentially bounce up and down on their energy levels, which causes them to they become so energetic that their energy level increases for a brief moment, and from that moment they then release electromagnetic waves before jumping back down, and these photons, as some might call them, then traverse through space, and when they hit other particles, they can imbue those particles with energy, causing heat in those objects. So why did I go through such a long explanation of this process? Simply so that people understand that the heat caused in a spaceship that's close to a star isn't necessarily because of the particulates of the star. Now, that being said, stars oftentimes do release a large amount of particulates, which, of course, would, upon contact with the spaceship, cause a heat increase. However, if the spaceship has any shield worth its salt, it should be able to, of course, block such particulates. Because if you think about it, for an interstellar traveling spaceship, or a spaceship that travels at very high speeds for space, if you're colliding with a fast-moving object in space, even if it's a grain of dust, and you're maybe moving at, let's say, 90% of c, you're going really fast, you hit that object, that can cause an enormous explosion. And that's why spaceships have to either have really good hulls or really good shields. And also, in addition to that, so the minimum amount of shield coverage to be expected by a shield in science fiction is to be able to cover any damage caused by particles in the interstellar and the interplanetary medium, small particles, dust particles, when the spaceship is moving through that. Of course, the degree of protection needed from that depends on how fast it moves through the medium. For example, a lot of faster than light speed technologies bypass normal space, so that isn't really an issue for moving at super relativistic speeds. But nevertheless, there's still a large amount of speed required when you're moving interplanetary. In addition to that, they also need to be able to block basic radiation when not near stars. For example, if you were to, let's say, move to a space station that orbited the sun, and that's far from the planet Earth, and it orbits the sun, even if it's, let's say, farther away from the sun than the Earth, you would have to deal with a large amount of radiation that normally is shielded by the Earth's magnetic shield, and all these radiations and particles can hit you and can cause all sorts of different damage, including can massively increase your chance of getting cancer. And if you are in a spaceship that is moving at between planets and between stars, and you're spending a lot of time outside of a planet's magnetic field, you're going to need some sort of protection, whether that is some plating on a spaceship's hull that is thick enough to, or dense enough to resist basic radiation coming from the cosmos, or a set of shields that is capable of doing the same thing. So when you're lowballing shields, I just want to make sure that you don't lowball below those levels. In addition to that, what do I have to say in addition? Holy cannoli. Also, a big issue is, how are shields powered? And how do shields remain powered? Do shields have their own power buffer or power capacitor that can run low and requires a longer time to recharge than the shield output is? Or what I'm trying to say here is there a step between the power plant of the spaceship, or whatever it is that the shield has, whatever power generator, and the shield emitter, or whatever you use to put out the shield? So the power generator and the shield emitter, is the energy that the shield emits, the energy that the shield uses, greater than the energy that is being put through to it? And does it therefore require a power buffer? So that means that a shield can run out and cannot really be used effectively after it runs out, or at least it needs to recharge for a bit. Another way it can work is that the power output is actually greater than the shields, and for something to overcome the shields, or to actually put down the shields, it either needs to be greater in magnitude so that it punches through the shields and hits the spaceship, or you need to disrupt the shields somehow. In addition to that, another thing related to this is, what are the shields actually? For example, right now, for all this time, I've been talking about shields that are a form of energy that is constantly being emitted. But what if shields are an energy field that does not require to be constantly emitted, or has properties similar to solid matter? That is another possibility. I've seen that here and there. I can't really think of off the top of my head where I've seen that, but that is another possibility. So anyway, I hope you enjoyed. I haven't actually done really any scaling itself, but I've talked more about the theory behind scaling shields. So hopefully, if you yourself are a power scaler like I am, you found this useful for helping your scaling. And if you have anything to contribute in either regards to scaling in itself, or in regards to maybe you want to co-host with me, how about that? That would be really enjoyable. Or maybe you want to share some talent you have in that is somehow relevant to the series. Please do so, and tell me in the comments below, or send me an email. You can look at the information tab, I believe that's what it's called, on my channel, and you just go through a quick CAPTCHA. You can get an email address that you can send me an email say, hey, why don't we collab? Or you can even do that in the comments section, and I can contact you. How about that? I really would love to do that, to work with somebody else, so that you don't have to deal with my insane ramblings all the time, and so that maybe there's some more coherence. Maybe there's some better structure. I don't know. Maybe just maybe things can get better. Better is better. Better is good. Anyway, thank you all for watching, and I've been Anuiltus, and I will be seeing you all next time. Anuiltus over and out.